Hello friends, again welcome to my channel. Today we are going to discuss in short about what are the recalcitrant molecules. Now these recalcitrant molecules, these are nothing but the xenobiotic compounds. Now the xenobiotic compounds, these are foreign to life. That means these are not the naturally the part of the environment. These are the man-made substances and majorly which can be persist within the environment for the longer time period, that is for the months or for the years. These are highly inert in nature. Majorly, the different chemical structure of the compounds, these are made them or these are responsible for the biodegradation, like that of its their stability, their reactivity, hydrophilicity, swelling behavior. These factors, these are responsible for affecting their biodegradability. Now again the different physical physicochemical properties, their molecular weight, their porosity, elasticity, morphology, all of these are also responsible for contributing for their biodegradation. Now the recalcitrant nature, it means the structural immitant stability of these molecules. Majorly these can withstand or these can resist the biodegradation. So due to that, these xenobiotic components, these are recalcitrant in nature, or in other words we can say that those of the xenobiotic components which can resist the biodegradation, these are called as the recalcitrant molecules. Now, majorly, this recalcitrant nature of the xenobiotic compounds, these are due to the different specific properties. The first one it is they are not recognized as a substrate by the existing degradative enzymes. As the microorganisms, they are responsible to degrade these components with their enzymes. Preferentially, as these xenobiotic components, these are not naturally present. So due to that, these are not continuously get exposed to the microbial cells. Due to that, these their enzymes, they are not considered them as an substance because these are new to the microbial enzymes. Again, the second one it is their highly stable structure. That means these are chemically and biologically inert molecules due to the presence of the substitution group like that of the halogens, nitro, sulfonate, amino, methoxy or the carbonyl groups. Again, the next structure it is they are insoluble in water. So as they are insoluble in water, these cannot be easily get absorbed by the microbial cells. They are highly toxic. Then their higher molecular size which prevent their entry inside the microbial cells. Again, the inability of these components to induce the synthesis of different degradative enzymes. That means there is the lack of permease enzymes which is needed for their transport within the microbial cells. Now there are the six different types of the recalcitrant xenobiotic components. The first one it is the halocarbons, second one it is the polychlorinated biphenyls, third one it is the synthetic polymers, fourth one it is the alkyl benzyl sulfonate, fifth one it is the oil mixture and the sixth one it is the other different type of the components. The different structural features of the xenobiotic components which make them resistant to the microbial degradation or which is responsible to increase their recalcitrant nature. It includes the presence of halogens in the place of hydrogen within the ring structure, because the carbon halogen bond it is highly stable. The substitution group of hydrogen by other groups like the nitrosulfonate, methoxy or other groups. Then their cyclic structures. Then the aromatic components, cycloalkyls, heterocyclic components. These are also recalcitrant or they are resist the biodegradation because within them there is the presence of the cyclic ring structure instead of the linear chain. Linear chains they can be easily get degraded by the microbial enzymes. Presence of the branched linear chains which resist the biodegradation. Then their more complex structure it is also then their large molecular size and insolubility in water. Now one by one we are describing about these components. That is first one it is the halocarbons. Now these halocarbons, these are the components which are containing the different number of halogens like that of the chlorine, bromine, fluorine or iodine atoms instead of the hydrogen atom. They can be used as a solvent like that of the chloroform, as a propellant within the spray cans of cosmetic paints, in the condenser unit of the cooling systems, that is the freons, chlorofluorocarbon. They can be also utilized as insecticides like that of the DDT. Then the herbicides, that is the dalapon. The C1C2 haloalkanes like chloroform, freons, they are volatile and escape within the atmosphere where they can destroy the protective ozone layer also, that is leading to the increased UV radiation. Then the pesticide like that of the herbicide, fungicide or insecticides, they are applied to the crops through which they can be leached into the water bodies and they are maybe subjected towards the biomagnification. The second one, it is the polychlorinated biphenyls, that is the PCBs. These compounds, they have the two covalently linked benzene rings having the halogen substituting the hydrogen. They can be used as a plasticizers, insulator, coolants in the transformers and also the heat exchange fluids. They are both biologically and chemically inert due to the presence of the number of chlorine atoms. Along with the increase within the chlorine atom, there is increase within their stability. The third one, it is the synthetic polymers. These are the compounds like that of the plastics, that is polyethylene, polystyrene, polyvinyl chloride and the nylons. They are used as a garments, wrapping material. They are recalcitrant mainly due to their insolubility in the water and high molecular size. The fourth one, it is the alkyl benzyl sulfonate. These are the surface active detergents which are superior to the soaps, within which there is the presence of the sulfonate group and which are responsible for resisting the microbial degradation. The other end, it contains the non-polar alkyl end, becomes recalcitrant if it is branched in nature. Whenever the branched in structure it is present, it is responsible to resist the microbial degradation. At present, the alkyl benzyl sulfonate having the non-branched alkyl ends, they can be utilized because they can be get biodegradable through the beta oxidation from their alkyl ends. The fifth one, it is the oil mixtures. Now, as we all know that oil, it is a natural product and it has many components and which can be biodegradable at a small scale. But whenever at the large scale, the large oil spills, at that time it is responsible for creating the pollution problem. The oil, it is recalcitrant mainly because of its insolubility within the water and due to its toxicity of some of the components which are present within the oil. Then the other xenobiotic components, it includes the number of different pesticides which are aliphatic in nature or the having the cyclic ring structure containing the substitution group like that of the nitro, sulfonate, methoxy, amino or the carbonyl groups. In addition, they are also containing the halogens and these substitution groups which are present instead of hydrogen, they are responsible to increase their recalcitrant nature. So here it is the information about the different types of the recalcitrant molecules. So if you like this video, please subscribe my channel and also share this video with your friends. Thank you.